Hello, this is Captain Chaudhari in my series of videos on marine astronomical navigation. Today I'm going to talk about some interesting things about the moon. We already covered a few. Today I'm going to talk about the varying declination of the moon in different lunar months. Like in case of sun, we say that the declination of the sun varies from, it changes from 23.5 degrees north to about 23.5 degrees south. But the maximum declination of the moon is fixed. More or less fixed. But in case of moon, every month, every lunar month, you will find that the maximum declination limit of the moon is not fixed. It changes. Today I'm going to explain you, today we are going to learn why this maximum limit changes in case of moon. For that, we must first understand what are these ascending nodes and descending nodes, and we must also understand that the orbit of moon is not coplanar with ecliptic. Orbit of moon is inclined by, on the average, about 5.25 degrees with the plane of ecliptic. So if we look at the equinoctial and ecliptic, sometimes the moon's orbit could be like this. At other times the moon's orbit could be like this. You see, this is because the nodal points are regressing westwardly continuously. Suppose this is the Earth, and suppose this is ecliptic, because ecliptic is made up of these two heavenly bodies, that is the Earth and the Sun. But the moon does not revolve around the Earth in this fashion, right? Assuming that the Earth is revolving around the Sun in this plane which I am showing. So this is the plane of ecliptic, but moon's orbit is this way. It's inclined by about 5.25 degrees this way. The orbit of moon is not coplanar with the Earth's orbit, and not only that, if we say this is ecliptic, as you see from top, there is a point at which the moon's orbit, as the moon revolves around the Earth in anti-clockwise manner, as you see from top, or eastward manner, there is one point at which the moon's orbit takes the moon from south to north of the ecliptic. That is called ascending node. And there's another point 180 degrees away, that is called descending node. Now this ascending node and descending node, as you know, on the ecliptic the sun would be seen traveling eastwards, right? Sun travels eastwards on its annual journey. You will find that contact point between the moon's orbit and the ecliptic, that is called ascending node and descending node, they regress westwardly at an average rate of, approximately 19 degrees per year. To be precise, 19 degrees and 21 minutes per year. The ascending node, starting from a fixed point, comes back to the same point in about 18.6 years. So 18.6 years is the period whereby ascending node, having regressed the complete 360 degrees westwardly, comes back to the original position, which means that half of this period, 9.3 years, the ascending node will take the position of descending node, and descending node will take the position of ascending node. Let's consider a situation. Say suppose this is equinoctial, and let's say this is ecliptic. This point therefore should be having written V here, west and east. This point should be first point of Aries. Now let's take a situation where the ascending node, where the moon's orbit goes from south of ecliptic to north of ecliptic, is in line with the first point of Aries. If that happens, the maximum declination in that particular lunar month is going to be 23.5 degrees plus 5.25, that is 28.75, 28.75 degrees north as well as south. So moon reaches this point, which is 28.75 from equinoctial, and same thing in the southerly declination. So let us see what happens after 9.3 years. After 9.3 years, the descending node, that means the moon's orbit going from north of ecliptic to south of ecliptic, the descending node, is in line with first point of Aries, right? So when this happens, from here to here is 23.5 degrees, and this is 5.25. So 23.5 minus 5.25, that means 18.25, right? 18.25. Declination in that lunar month will be 18.25 north to 18.25 south. That means the moon's declination in a lunar month would be anything from plus minus from north south 18.25 to 28.75. This is because of regression of nodes westerly. Let us say this is a celestial sphere. It's representing the ecliptic. Ecliptic is a great circle celestial sphere showing the movement of sun. So this is the path of the sun eastward on the celestial sphere, and the common point between the moon's orbit and ecliptic are ascending node and descending node. And suppose these two are the nodal points, right? And let us say for the timing sun is here. Now the sun's movement eastward is completed this way, 360 degrees, 365.25. And the ascending node's annual movement is 19 degrees 21 minutes. So the total amount moved by the two is 19.35 plus 360 degrees, that is 379.35. That means the rate of separation of the ascending node or descending node with the sun on ecliptic is 379.35 per year. That means to cause a separation of 360 degrees, it will take about 346 days. To be precise, 346.62 days. So this is the synodic cycle of ascending nodes or descending node. See, 19 synodic revolution and 223 lunar months. They are of the same period. Same time these two things are completed. That is 19 synodic cycle and 223 lunar months. Right? So this is about 18 years and 11.33 days. So they say that after this interval what happens is the similar tides should repeat.